The recent announcement by scientists at the University of Cambridge has reignited one of humanity's oldest and most profound questions. Are we alone in the universe? Their research suggests what they describe as the strongest evidence yet for possible life beyond Earth, centered on a distant exoplanet known as K2-18b. Located approximately 124 light-years away, K2-18b has been observed using the powerful instruments aboard the James Webb Space Telescope, a technological marvel designed to peer deeper into space and further back in time than any telescope before it. What makes this discovery particularly compelling is the detection of specific molecules in the planet's atmosphere that, on Earth, are closely associated with biological activity. According to the researchers, there is a reported 99.7% probability that these molecules could be linked to processes that support life, a level of confidence that is rare in astronomical observations, and yet still falls short of the strict standards scientists require before making definitive claims. K2-18b is classified as a sub-Neptune exoplanet, meaning it is larger than Earth but smaller than Neptune, and it orbits within the habitable zone of its star. The habitable zone is often described as the Goldilocks zone, where conditions may be just right for liquid water to exist, not too hot and not too cold. This alone does not guarantee life, but it makes the planet a prime candidate for further study. Using spectroscopic data from the James Webb Space Telescope, astronomers analyzed how light from the planet's star passes through the planet's atmosphere. This method allows scientists to identify the chemical fingerprints of molecules present in that atmosphere. In doing so, they detected two molecules that immediately caught their attention because of their strong association with life on Earth. On our planet, these molecules are known to be produced primarily by microorganisms, particularly those living in ocean environments. Microbial life in Earth's oceans plays a crucial role in shaping our atmosphere, releasing gases as byproducts of metabolic processes. The detection of similar molecules on K2-18b raises the possibility that comparable biological processes could be occurring there. Some scientists have proposed that K2-18b may possess vast liquid water oceans beneath a hydrogen-rich atmosphere, creating conditions that could, at least in theory, support microbial life. However, this interpretation remains controversial, as other researchers argue that the planet's environment could be very different from Earth's and potentially hostile to life as we know it. Astrophysicist Avi Loeb of Harvard University, a prominent and often controversial figure in the search for extraterrestrial life, has weighed in on these findings with cautious curiosity. Loeb emphasizes that while the presence of these molecules is intriguing, it does not constitute definitive proof of life. On Earth, the same molecules are indeed produced by microorganisms, but they can also arise through non-biological processes under certain conditions. Loeb points out that without absolute certainty, scientists must remain careful not to overinterpret the data. In physics and astronomy, a gold standard known as 5 sigma is often required before a discovery is considered conclusive. This level of confidence corresponds to a probability of about 99%, significantly higher than the already impressive 99.7% cited in the current research. Loeb's perspective is shaped by his broader work in the field of extraterrestrial research, where he consistently challenges conventional assumptions. In 2023, he and his team reported the discovery of metallic spherules retrieved from the ocean floor, believed to be fragments from a meteor that entered Earth's atmosphere. Loeb has suggested that these spherules could potentially be remnants of extraterrestrial technology, a claim that has sparked both fascination and skepticism within the scientific community. While research into these materials is ongoing, the episode highlights Loeb's willingness to explore unconventional possibilities while still insisting on rigorous scientific scrutiny. When it comes to K2-18b, Loeb underscores an important caveat. The same molecules detected in the planet's atmosphere have also been observed on comets, which are widely considered lifeless. Comets contain a rich mix of chemicals formed through geological and chemical processes that do not require biology. This raises the possibility that the molecules on K2-18b could have been produced through purely abiotic mechanisms, such as chemical reactions driven by heat, pressure, or radiation. In this scenario, the presence of these molecules would not indicate life, but rather a complex and interesting planetary chemistry. The debate over biological versus non-biological origins of these molecules illustrates a central challenge in astrobiology. Life, especially microbial life, does not leave straightforward signatures that are easy to distinguish from non-living processes. Scientists must rely on indirect evidence and build cases based on multiple lines of observation. This is why extraordinary claims require extraordinary evidence. While the findings from K2-18b are exciting, most researchers agree that they represent an important step forward rather than a final answer. Another layer of complexity arises when considering communication with potential extraterrestrial life. Even if life does exist on K2-18b, it is almost certainly microbial, at least based on current evidence. Intelligent, technologically advanced civilizations are far more speculative. Still, the sheer distance involved presents a formidable barrier. At 124 light-years away, any signal sent from Earth would take 124 years to reach the planet, and any response would take another 124 years to return. This means a minimum wait time of 248 years for a round-trip communication, assuming the recipients were able and willing to respond immediately. Loeb has reflected on this reality with a mix of humor and philosophical insight. He has remarked that waiting centuries for a reply is not particularly practical or appealing. Instead, he argues that humanity should focus on listening rather than broadcasting. This approach aligns with ongoing efforts in the search for extraterrestrial intelligence, or SETI, which involves scanning the cosmos for signals that could indicate technological activity. According to Loeb, listening first is not only scientifically sensible, but also metaphorically wise. He likens it to human relationships, suggesting that in any meaningful interaction, the best first step is to listen before speaking. The discovery related to K2-18b also highlights the transformative impact of new technology on our understanding of the universe. The James Webb Space Telescope has already exceeded expectations, providing unprecedented detail about distant planets, stars, and galaxies. Its ability to analyze exoplanet atmospheres marks a new era in astronomy, one in which scientists can begin to assess the habitability of worlds far beyond our solar system. Each new observation adds to a growing database that will help researchers refine their models and distinguish between biological and non-biological signatures more effectively. While public excitement around the possibility of alien life is understandable, many scientists stress the importance of patience and perspective. The history of astronomy is filled with discoveries that initially seemed revolutionary, but later required revision as new data emerged. At the same time, there have also been moments when careful, incremental research led to profound shifts in our understanding of reality. The search for life beyond Earth sits at the intersection of these two traditions, demanding both imagination and restraint. Ultimately, the findings about K2-18b represent a milestone rather than a conclusion. They suggest that the ingredients or conditions associated with life may not be unique to Earth, and that the universe could be more biologically rich than previously assumed. Yet they also remind us of how much we still do not know. Whether the molecules detected on K2-18b are signs of living organisms or the result of exotic chemistry remains an open question, one that will require further observation, more advanced models, and perhaps entirely new methods of investigation. For now, the planet stands as a tantalizing hint, a distant world that challenges our assumptions and fuels our curiosity. As scientists continue to study K2-18b and other promising exoplanets, each new discovery brings us closer to understanding our place in the cosmos. Whether or not life exists elsewhere, the pursuit itself reshapes how we see Earth, life, and the universe as a whole, encouraging us to look outward with wonder while remaining grounded in evidence and reason.